All right.
Hi.
Hi, there we go.
It.
Woohoo. It worked. That's awesome. All right. So I'm open for questions. So if you have any specific questions that you want to go over,
I don't have any, well, it's not a specific question, but I was wondering if we can go over any of like the questions in the lab, because last time when we did that, it helped me a lot understand the lab and the formulas and everything compared to lab 2 or 1.
Mm-hmm.
Yeah, because like when you show us the formulas, like I can practice while we're doing it, so I know for each one, if that makes sense.
What to do?
Yeah.
Okay. So let me go to just a second here. Let me go to my screen, or let me go and get, just give me a second here. And student view. And going to assignments. And which one is it? Lab number 4, right?
Yeah.
And let me share screen. Share screen.
I have 2 questions that are just clarifying questions before we.
Yes, absolutely.
Awesome.
All right.
One is that for question number 13 in the sheet that here we are. Okay, so what do we have here? So we have alpha 1 for the test, conducting the test, but in the lab answers, I think it's alpha 5.
Uh-oh. Is it? Oh, no.
Because I was just checking my answers, and I was like, oh, crap. I mean, it worked because you still get the same, the T-score that you get is appropriate to get the same response. But,
you're right. It's a 0.05.
Yeah.
Huh. Because in my, that's weird, because on my quiz, I wonder why. Huh. Let me change that to a 0.05.
Okay.
All right. Yeah, I'm going to
to
change it to a 0.05. Yeah. Let's do that. Let me go in there real quick and do that now. Access denied. Okay, leave student view. Billing. See if I can actually, yeah, no, I can go back. Just here. Let me edit it because I think it'll be. Is that the only one?
That was the only one that I found. Yeah, and then my other question was just like
everything was okay. Everything else was good.
I think so. Yeah, totally.
Oh, good. Thank you. Yeah. No, thanks. I appreciate that. So it was number 13.
Mm-hmm.
I'll go ahead and change that to 0.05. Okay, it's changed.
Awesome. So my question, that's just like a clarifying, is I noticed that when I fail, so do we do a confidence interval no matter what, whether we reject or fail to reject, always a confidence interval?
Mm-hmm.
Okay, great. That's all I need.
Yeah, I think I did that. Yes, I did that for all of them. The only thing that you would not do when you fail to reject is the effect size.
Okay, yeah.
Right, so the effect size is only calculated when you reject, it's only calculated when you reject the null hypothesis.
Mm-hmm. Got it.
So the confidence interval, you always put it in because what it does is it strengthens your evidence that it is a fail to reject.
Mm-hmm. Is
basically what you're showing is that yeah, it's definitely a fail to reject, because even in the confidence interval, you'll notice that the mean is in that actual confidence interval.
Got it. That makes sense.
Yep.
Okay. Those are now. I'm just along for the ride.
Okay. Yay. Something might pop up as we're talking. Who knows, right?
That's what I'm here for.
All right. Very cool. Awesome. Okay. So what questions do we have? How do we want to work this?
So I guess like my question is because it's just so much information.
Oh yeah. Mm-hmm.
I'm kind of getting confused with the null hypothesis, like null 0 and then null 1. I forget what.
Okay, the null H0 and H1.
Yes.
So the null hypothesis is H0, and the alternative hypothesis is H1.
Mm-hmm.
Right? The null hypothesis is always the statement that says or that states, right, that there is no difference.
Okay.
That whatever's happening in my sample is not any different than what's happening in the population. That's your null hypothesis. There's no difference. There's no effect. You know, if I do a treatment of some kind, there's no effect whatsoever. That's the null, okay? The statement of no difference, nothing happened or nothing's going to happen, right?
Mm-hmm.
The alternative hypothesis, and this is usually what the researcher is trying to find, right? Evidence for, okay, is usually what we're trying to find evidence for is for that alternative hypothesis. And the alternative hypothesis is typically that statement that there is a difference, right? There is an effect. There is that the treatment worked, or you know what, my sample is not the same as what's happening in the population, right? There's something different about my sample, right? Okay, that's the alternative hypothesis.
Yeah, because I was I'm doing the PowerPoint notes because again I always find them easier, and right now I'm on chapter 8. I'm gonna be on lecture 4.
There's a lot. Oh my God, you're so far behind.
I can do it, Professor. I can do it.
I hope so. Yeah, this is kind of late because we're already Monday night, and you've got a lot of material to cover if you're just on chapter 8 now.
Well, I did some of the reading in the Senate.
Okay, good. Okay,
again.
Okay, good.
Yeah.
Okay, good. All right.
I just find again like sometimes reading the book is like.
I know. So, okay, so a couple of things. So some of the things that kind of go wrong, okay, when I look at these exams, when, you know, in the past, when I've looked at stuff, one of the things is to know what test, right, to actually do. So what is it in the problem that's going to give you a hint of what kind of test you need to actually conduct, right? When I say conduct the appropriate hypothesis test, I'm not telling you which one to conduct, right? You have to figure out which one to conduct. Hi, Paris Dew.
Hi.
You made it back home.
Hi, everyone.
That was fast. So the test is you're going to have to figure out, and it's going to be based on the actual problem, right?
Okay.
And so let me go back to my lab, my student view. So when you look at the actual problem, like for example, Lindsay, you were talking about number 13. When you look at this particular problem, one of the things that you'll notice is that these are two different groups, right? There's the caregiving wives and there's non-caregiving wives, right? These are separate, different groups, okay? And so if they're different and they don't, they're not connected in any way, these are two independent samples, right? You guys with me? Right? And so the type of test that you're going to need to conduct here is going to be the independent samples t-test, right?
I got one more. I found one more discrepancy between the lab assignment and the lab answers.
Okay.
In the lab assignment, questions 16 and 17 are free response. You know, when should a researcher use? Yeah, exactly. And then in the answer key, those are not there.
Oh yeah, I don't put them in there because that's based on the textbook.
Okay, great. I just wanted to make sure because the answer key has problem 17 as problem 19 and etc.
Oh, yeah, you're right. Okay. So that's
So
actually,
that's
yeah.
fine. I'll absolutely, I know
Yeah,
the
so these
answer.
are 19. These are supposed to be 19 and on the answer key. So
19.
17, on the answer key, 17 is actually number 19 and 18 is actually number 20, right?
I just wanted to make sure that, okay,
Yeah, thank
perfect.
you. Yeah. No, I don't put those in there. And the reason for that is because there's actually these answers come straight from the PowerPoint, my video lectures. These are straight from the video lectures, and it's also in the textbook too. The textbook actually talks about these too. So I'm not going to give you the answers to those. You can look those up.
Absolutely.
Yeah, it's just easier to do that. I didn't realize that I did that on the answer keys. But thank you for saying something about that.
For sure. I have a question. When we're stating the null and the alternative hypothesis, the book keeps it very general. So I trended towards that. For example, just question 1 to state the null and state the alternative. My null was the new drug will not improve memory.
Okay.
But then when I read in the sample answers, you definitely give it more life. You take in consideration the patients and the storyline, and the book very probably because they're teaching us in the book like exactly the basic.
Right.
They keep it more straightforward. Which do you prefer, and what should we learn to do in the world? You know.
Well, in the world, when you're say, so for example, let's say that you are, you go on and take a different some more statistic courses. The null hypothesis, you're going to want to be as specific as possible, right? Because when you're not the null, but especially with the alternative hypothesis, because that's really what you're testing. And so you want to make sure that you're as detailed as possible so that people who are looking at your study know exactly what it is that you are testing.
Okay.
Right?
So, I wrote mine all way too simply.
Go ahead.
I wrote them all way too simply. Just it does work or it doesn't work.
Yeah, and that's fine. I mean, because you're learning, right? And so as you're learning and as you get more experience, you're gonna learn to be more and more specific about these. And especially, when you start looking at journal articles, you'll notice that the researcher will specifically say what it is that they're testing. Right? They'll say like this here, participants that are taking the new drug are not going to recall or will recall more words than the untreated population, right? And for the purposes of this particular class, as long as you get the gist, right?
Yeah.
And if it's a directional, it's directional. The null and the the alternative are directional, and if it's not if it's two-tailed, right, it's non-directional. So I mean, I'm looking for those specific things, and it has to be in terms of the problem, right? Yeah. And hopefully you can show me that you understand what the problem is actually asking you. And typically, what I recommend is the question itself. When you look at, like, so for example, do they recall more words than the general population, right? So you can actually use this terminology, right, when you're actually writing the null hypothesis, right? So you could say, do participants who take the drug, not do, but the participants taking the drug will recall less words than the same amount of words as the general populations, right? And then the alternative would be the participants taking the new drug will recall more words than the general population. I mean, you can actually use the wording that's in the actual question itself to help you formulate what the alternative especially the alternative hypothesis needs to be. And then the opposite is your null hypothesis. Cool. And I think I did some sample videos. Did you get a chance to take a look at the sample?
Yeah. I've looked at all of them. I just kind of balanced between your videos and the book, and so I wanted to clarify.
Yeah. Those are more.
Just show me that you know.
What the null hypothesis is, right? So you could say, do they recall more words than the general population, right? And then the alternative would be the participants taking the drug will recall more words than the general population. I mean, you can actually use the wording that's in the actual question itself to help you formulate what the alternative and just show me that you know you know, as long as I can see that you're understanding A, the problem, B, what a null and a alternative is, then yeah, you're fine.
Okay.
And the
Awesome.
symbols, especially the symbols too. That's all,
Totally.
you know, I'm looking at making sure that the symbols are right.
Yeah.
Okay. Yeah.
Yes.
Cool.
Thank you.
Yeah, of course. And if the question asks you to do it in symbols and in words, then it, you know, you need to make sure that it's in the symbols and then the words, just like the example, like the answers I have, right?
Yeah.
Yeah. And I also recommend when you're working out the problems that you use the steps. I've gone through and I've actually, like, step 1, right? The hypothesis test, right? Step 1, state your hypothesis. Step 2, set the criteria. And the criteria, you'll always be given the alpha level, always, right? It's going to be 0.05 or 0.01 or, you know, whatever. And then based on that, you can look up your T critical. Well, that's one of the criteria for the T critical, because remember, there's 3 things you need for T critical, right? You need your alpha level, you need the sample size, right, to figure out what your degrees of freedom are, and then you're going to need whether it's a one-tailed or a two-tailed test, right? And do you all know how to tell whether or not it's a one-tailed or you know what to look for?
Yeah, I have it in my notes here. I'm finding it.
How do you know whether you're dealing with a one-tailed or a two-tailed test?
I haven't gotten that far yet.
What's that, Alexis?
I haven't gotten that far yet.
You haven't got that far yet?
An increase or a decrease, or is it just a change?
Right, exactly. So, and if it gives you the direction, right? So if it tells you, if it asks whether it's going to increase or decrease, is it less or more, improve or it decreases, right? Or it lessens, right? Those are all directional, right? They're giving you the direction, right? More is up, less is down, right? So if there's a direction, then it's a one-tailed test. And it's in the question, right? So do they recall more words, right?
Mm-hmm.
So is this directional or is this non-directional?
For which?
For this one, number 1.
Oh, let me look at it.
Do they recall more words? Is it giving us the direction?
No. Right.
More words. The key term is more.
Oh, then yes.
Yeah. There's more. Are you increasing or decreasing, or you have no idea?
I want to say increasing because it's saying more.
Increase. Yeah, you're increasing, right? So the drug is going to increase the recall, right? So it's telling you, it's telling you that it's going to be on the right side of the distribution, right? It's telling you that there's a direction, right?
Yeah.
Okay. So that is always a one-tailed test. Okay.
Okay.
If you get a question, on the other hand, and I'm gonna scroll down. Sorry for the scrolling. I'm trying to find one that is. Here we go. Do these data indicate a significant difference in hope? Is there direction here?
No. No.
No. Do you know? Is it going to increase, decrease? Is it asking that?
No.
No, not at all, right? So when you see the word difference, that means change. There's some kind of change, but like Lindsay, you said change, right? There's some kind of change, but we just don't know what kind of change is going to occur. Does that make sense?
Mm-hmm.
Yeah. And so this word right here, difference, or you could say, do these indicate a significant effect, right? An effect is the same thing as a difference, right? An effect, difference, change, whatever. Those are two-tailed tests. right?
So, Professor, can we stay on this question 13?
Can we what?
Can we stay on this? Can you guys hear me?
Yes, I can hear you. You want to stay on this one?
Yes, I just had a quick question because I did step 1 correctly and I did,
Perfect.
and I had a question for step 2.
I'm going to reset this real quick. I'm going to reload this so that it shows 0.05. There we go.
Sure.
Oh, let me reload. Let me refresh mine because I didn't even do that.
Yeah, so I
Okay.
didn't change it. Oh, darn it. I got to go back and go back into student view because I got bumped out. Dang, nabbit. 4, there it is. Okay. Okay, so number 13. There it is. Okay. All right. So where did you have a problem?
So if alpha equals 0.05, and this is two-tailed, right? Because we were
Yes.
just discussing.
Mhm.
How does your t critical value is? So if we look in the chart, we're going to see that it's 2. It's positive because it goes up. Because I found the numbers of
Based on degrees of freedom, right?
yeah, I found it as 52, the degree of freedom.
The degrees of freedom are 52. Okay, so this is a really good question. So what do we do when the number is not there?
Oh.
Yeah.
Right? Because 52 isn't there.
So that's
Right?
it. It's
not. It goes from 40 to 60, right? And so, and I think your book actually talks about this. You need to take the 60 because it actually includes the 52, right? So it'd be plus or minus 2.
It also
Do 40. If you did 40, it doesn't include 52. 52 is not in there, right?
yeah.
So you have to use the bigger DF. You have to look at the row with the bigger degrees of freedom.
Larger degrees of freedom. Got
Right?
it. Yeah. Yes. And it's harder to reach that 2.0 as opposed to the 2.21, so it validates it even more.
Right.
Sort of.
Yeah.
Maybe.
It is. Yeah. It's a yeah.
Okay.
So then we calculate the test statistics with M1 and M2.
Well, you're not ready for test statistic yet. You got to prep it, right? The T, you have to figure out. You're going to have to figure out what estimated standard error is, right? And before you can figure out what estimated standard error is, you're going to have to do some stuff.
Right. So if I find the estimated standard error, found a 0.491. No, but it's not right. When I go to what you have, my numbers
Don't match.
don't match. So
Uh-oh. Well, okay, so there's a couple things that you need to take a look at, okay? So first of all, when you're looking at the actual numbers, what you'll notice is that both of these, the ends are equal, right? And is equal to 27 for both of the groups, right?
correct.
So yay, we don't have to do a ton of calculating. Whew, right? You've got your sample means for both groups, right? And you have your variance, sample variance for both groups. So sample variance is already given, right? And I'm going to go back up and I'm going to do the formula sheet real quick. Okay. So here's the formula sheet, right? Oh, and by the way, I want to give a hint here. The formula sheet is actually set up where you can actually draw lines where all the, like, so if you have to do like a Z test, right? Here's your Z formulas, right? And everything you need for the Z test, right? If you're doing a one sample t-test, here are all of your formulas for the one sample t-test. When you're doing an independent samples t-test, here are all the formulas. Actually, it's these 2 rows, right? Here are the, actually, no, it is all of these. It's all these 1, 2, 3, 4 rows for the independent samples t-test. And for the related sample is on the next page. Right?
Okay. Yeah,
so I've actually grouped everything.
Yeah.
I try to make this as simple as possible, right? So that if you know what you're doing, you know right where you need to go, right? And so what I always recommend to students, and especially if it's a face-to-face, but even online, print this out, draw the lines, and you might want to put a little note next to that. Okay, so this is independent samples, this is related, this is single, this is Z, right? So that way it's already like, okay, I'm good to go. Just a hint, if you want to. It might help.
I was looking at this and I was like, oh.
I know, it's super overwhelming because there's like tons of formulas. It's like, oh my God, what do I do? So it's always a good idea to go in, right? So here, you know, this is sample mean, right? This is your sum of squares. This is your sample variance. This is your sample standard deviation, right? So it's always a good idea to, you know, if you want, print it out, write down what these are. So that way you're not like trying to figure out, okay, so what is this? What am I supposed to do here?
Yeah, because again, like I said, Professor Wayne, we did the last online meeting like this for lab 2, I believe, or lab 3.
Lab 3.
Yeah, so like so much. When we did lab 3 and you did some of the examples like on 14 and 17, I think, which was hard, it helped me like understand the formulas better and know what to plug in instead of going back on my notes because I had like the example.
Right. But I actually have videos.
I know.
I have these, I have problems just like the stuff that's on the lab. I have videos of sample problems that you can actually watch and take a look at to see how to set them up and how to go through them. So you can go through those.
On your last PowerPoints, when you showed the examples in your videos, what I like to do is like print the PowerPoint, and then if the videos are after, I like, if I have a blank page or sheet, I will write it on the back of that PowerPoint so I know this belongs to chapter 8 and like this formula belongs with this module, so I don't get confused with all of them.
Right. Yeah, that makes sense. Yeah. Good. That's awesome. That is awesome. All right. So going back to this problem, right? So S squared, when you look at this formula sheet, right? So, you know, step 1 is to write out the hypotheses. Step 2 is to figure out what your criteria are, right? And then step 3 is to do all of the calculations, right? And so with an independent samples t-test, because that's what 13 is, it's an independent samples t-test, right? There's a few things that you need to remember. Number 1 is there depending on the sample size for the groups, you're going to use different ways to approach this or to calculate this, right? If the n's are equal, it's really super simple, right? You're going to go straight to estimated standard error, and here it is, right? If the sample sizes are unequal, we have to add a step, and that's your pooled variance. Okay? These two, the first row here, this row right here, these are both pooled variance formulas. And depending on what information you have, like for example, let's say number 13 had been unequal n's, but you were given sample variance, you would have used this formula here because there's sample variance, right? sample variance times degrees of freedom is equal to sum of squares. Because when you look at the sum of squares, this right here, right? Remember this formula here? Sum of squares. Actually, this is sample variance. If I were to do some algebra, right? Some crossing out and all that good stuff. N minus 1 is degrees of freedom. So if you multiply both sides by the degrees of freedom, that's your sum of squares, which is equal to degrees of freedom times sample variance, which is S squared. Now, one of the mistakes that I noticed on exam 1 was that some students actually took sample variance and squared it again. Don't make that mistake. If you have sample variance, it's already squared. It's already in squared units, okay? If you're given S, which is sample standard deviation, then yeah, we did take the square units out, right, by taking the square root. And so sample standard deviation is what you would square to get sample variance, right? You with me?
Yeah.
Yeah?
So
Okay.
in this problem, because they're the same,
I'm sorry?
this problem, they're the same. The ends are the same.
Right. So you don't need to worry about pooled variance for this problem. Unless you want to do a Cohen's d, where you would need to have pooled variance.
Oh.
Yeah, oh. Right? That would be the only reason you would do a pooled variance, is if you wanted to do an estimated Cohen's d. However, you don't have to, right? You don't have to, because with t tests, your effect size, you can do an R squared, right? And you don't need pooled variance. So you don't need to add the extra step if you don't want to. Okay? So you can go straight into the estimated standard error. So Haristu, did you rework your problem?
Yes, I'm going to when we're done. I want to listen.
Okay, so S squared, right? So the S squared, if you look at the, right? So it'd be 4.12 divided by 27 plus 6.55 divided by 27. So let me see if I can actually go in here. Hold on, let me do this real quick. Hang tight. All right, let me do submit assignment. Oh, I'm already in here. Okay, cool. So Control V. Okay, so here's the problem, right? So we do step 1, and you don't have to do this, right? So you state your hypothesis, right? Step 2, which is the set the criteria, right? And step 3. You can, if this helps to keep you like on track, but you don't have to, okay?
So, Professor, I have a question.
Mhm.
When it comes to us doing it, because you said for us to show your work, do you want us to write like the formulas and then plug it in, or can we just write the that makes sense?
Yeah, yeah.
Because when I was doing that, like again, I was like legit gonna turn everything in, and I was on like number 24 or 25.
Well, for the lab assignments,
Yeah.
it's a good idea to show what formula you're showing. But for the test, because of the time crunch, if you know, you don't have to actually show which formula you're using, because I should be able to tell by what you're doing. You'll need to make sure that you tell me what kind of tests that you're running, right? So what are you conducting, right? And also the symbols, right? You're going to need to make sure that you put in the symbols, right? T, Z, and all that good stuff, right?
Okay, yeah, because that was like one of my main questions. Because again, I always, if you've seen, like I put in my formulas. Again, like it says C equals I, just an example, like or the better example, I guess, is z equals standard deviation, or x minus the mean over standard deviation. I do it like that, and then I plug in like the numbers what they're supposed to be, but I didn't know if you want us to always do that.
So let me show you how you would set this up. So let me show you. So you know what the numbers are, right? So this would be 4.12 divided by 27 plus, what's the other number? 6.55.
The numerator is not squared?
No.
No.
This is the mistake that a lot of students make. Why isn't it squared?
Because it's
already
variant.
squared.
It's already squared. Look at the symbol. Look at the symbol. Always look at the symbol. It's s squared, right? And the formula, look at the formula. It's s squared. They match. Do not square it again. This is something that students do all the time. They will go in and square this again. Don't do that. It's already squared. Okay? Now, because these are equal, the beauty of this is that you can just go in and do, okay, so add the numerators. You don't have to figure out what this crazy decimal is going to be, right? You just basically figure out this is going to be 11.67?
10.67.
Is that correct?
10.67.
Is it 10? Oh, yeah, that's right. Thank you. Thank you, thank you, thank you. Yeah. I'm tired.
It's summer.
That too, and it's hot. And my brain isn't working today. So 10.67 divided by 27 is equal to 0.39. Please. Uh-oh. Why is that not the same? What did I do different? And what did I do wrong? 0.62. It should be, it says here 0.62.
Yeah.
I got 0.395.
Yeah, that's what I got too. Lindsay, is that what you got too?
That's what I got, yeah. 0.395.
Oh, that's the square root. Oh, the 395.
Yeah, got it. 0.62.
Yeah. Yeah. Oh, I'm like, oh my God. I need to stop talking. 5. Okay. All right. So this, now take the square root of that. There we go.
There it is.
There it is. Phew. Okay. Yes. Yeah. And this is another error that students will make. What I just did is they'll forget to take the square root. So they'll divide this here and then come up with 0.395185 and use that as the estimated, but it's not. Remember to take the square root of that, which is 0.6286. And when you're doing the calculations, leave your numbers out to 4 decimal places. And the reason why I suggest this is because as you're doing calculations and you're rounding, as you're doing the calculations, the numbers are going to get more and more inaccurate. Okay, so you want to make sure that you keep it out to 4 decimal places. You can do 3, that's okay. It should be still pretty close. But don't round up to 2 decimal places because it will be way off. Your final answer will be completely different. And that is going to be incorrect. Okay, so, and it'll be due to rounding error. So do not round up until the final answer. Okay?
But Professor, on my calculator, it says 0.6284.
No, it's 0.6286 is what I got.
Yeah, it says 0.628490.
Okay, so 10.67 divided by 27. And then take the square root of that.
I'm 100% on that. And the answer, as I see all the time when you give the answer key, is that I'm always off on my calculator by by rounding. I don't know. It doesn't. The full number is 0.628490254.
No.
Yeah, I have to remember.
Wow. That is really weird. Let me
See
see.
on my test that I'm off. It's because of my calculator. Obviously, I don't do this.
Is your calculator set? Because I'm getting 0.6286. 684. You know what? It may not make that big of a difference when we insert it into, because it's still 6.2, well, 6.28 versus 6.29. It may or may not make a difference. We could look. I mean, we could do. So the next step of this, right, is going to be the t statistic, right? We have everything we need. Because when you look at the t statistic, we have M1, M2, and we have we just calculated estimated standard of error, right?
Yes.
Yep. So we just got to plug it in. And so M1 is going to be 23.77. So let me, hold on. Let me go back into Math Editor. So T is equal to, and it's a fraction, and it's going to be 23.77 minus 26.31, and it's going to be divided by, and we can do both the divisions. I'm going to do it with my calculations, Peristu, and you do it with yours, and let's see if we get the same numbers. Okay? Well, you know what? We got to run the experiment. Let's check it out. Let's see. Okay. 23.77 minus 26.31. Yes, it's negative. Yes, yes. And that's okay, right? And remember, the reason why we're getting a negative, remember, it's on both sides, right? This was,
yes.
is there a significant difference? And so it's going to be on either on the left side of the distribution or it's going to be on the right side of the distribution. We didn't know. So it's going to be a negative t, okay? And this is why when you do your t critical, you have to put plus or minus whatever the t critical value is, because it could be a negative or it could be a positive, right?
Right.
So I got negative 4.0407.
All right, 0.6286, which is equal to, I'm going to divide this, 286, which is equal to, oops, I got negative 4.04.
Okay. So I just looked at it like, instead of 4 numbers, I read 5. Okay.
Well, I got 0.40407.
Okay, yeah, I got the same thing.
Okay, that's what I got.
Negative 4.0420.
There you go. But you can round it up to, yeah. And so you round it to the 4.04 and it's the same.
Beautiful.
And at this point, this is where you can actually round it. Now you're done, right? So you can use this 4.04.
Okay.
And notice how in the answers that I give, the t obtained or the the calculated t or observed, right, is rounded to 2 decimal places. This is where I round it.
So did we also need to get the s squared p?
No, you did not. Why not?
Well, it was, you had put it, so I don't know why.
Yeah, in case someone wanted to do it that way.
Ah, okay.
Yeah, that's the only reason I put it in there, is in case someone wanted to do, because you're going to come out with the same t regardless.
Yes. Okay, so that's just if, just like you said. Okay, good.
Okay.
Oh,
Yay! We did an independent samples t-test.
So, Professor, again, so when it comes to the exam, we don't have to type in the formula like
This
all
is
the
what you need
letters.
to do right here.
Oh, okay, because I don't know if you saw, but like I was typing all the letters like previous, and then I would plug in the numbers, and then it was taking a lot of my time. And I
me
was
too.
No, you
What
don't
did
need to do that.
you guys so?
Well, this will tell me, like, if you put estimated SM,
Mhm.
well, obviously, okay, this is the formula you're using, right?
Okay,
Or if it's T, or if it's Z, right?
okay, but we don't have to use the Greek letters for all of them like that, and then.
Well, if you're using like, for example, sigma M,
Mhm.
then yeah, you need to use that Greek letter. Yes.
Okay. Yeah. Okay. That makes it so much easier because I was like typing in like all the Greek letters before I was plugging in the numbers. I was like,
No, you just
God,
no. I will know by the numbers what you're using.
Okay. That makes it so much easier.
Or what you're trying to do. Okay.
Mhm.
Cool. Excellent. So what else? What other things? I'm trying to think of what else I see as an issue on a test, on the tests. Oh, when you look at, and I'm going to go to the actual answer key real quick. Let me go to the answers. So what you'll notice is that I have written out the results. So with step 4, where you're actually making your decision and you're writing out what the decision is, this is how it needs to look like, okay, in your lab and on your exam. And it has to be in this order, okay? And notice how you've got italicized symbols. I'm not sure if in the test you can actually italicize. I think you can. If I remember correctly, I think you still have the little like bold. Yeah, I think you can do the bold and the italicized. So this is scientific writing, and so it is specific to APA, which is American Psychological Association. And so this is how we write out the results. Okay, so there is sufficient evidence that Time Warner customers spend significantly more time on the internet than the general population, comma, and this is where I always see students where they put a period here, and then they'll put like the evidence on a separate line, and that's incorrect. It all needs to be together. Here is your statement, right? There's sufficient evidence that they spend significantly more time on the internet than the general population, comma, and there's your evidence supporting the claim that you just made. Right?
Oh, okay.
That's what this is. So it's Z parentheses n equal to 25, because we want to know how many people were in your sample, and whatever Z was equal to, right?
Okay.
Comma P, and with the Z's, you can actually look up your p-values, right? And remember, if this was a two-tailed test, whatever P is in the table, you have to multiply by 2 because it's in the both tails, right? So the table only gives you the p-value for one side, right? So if it's a two-tailed test, remember you need to multiply that p-value so that you get the right p-value here, okay? And then there's your Cohen's d, because we had a significant difference, right? And then we usually write, yeah, this is a medium effect, right? Because remember, Cohen's d, when we're looking at the criteria, 0.2 is a small effect, 0.5 is a medium effect, and 0.8 is a large effect, right?
What's the sigma M in
This
parentheses
is
for?
this is only here. I put it in there. This is not part of the actual decision. This is not included. The reason I put this in here was for you to double check your answers.
Okay.
That's the only reason why that's there. So anything in parentheses underneath, I think I did that in a couple of other places. I think there was one other place.
Yeah.
I think that I did. No, that was the only place it looks like. I thought I did it somewhere else. But where I write down like this here, right? No, this is, you need to actually work out the problem, not just provide the answers, right?
Mm-hmm.
But this is just to double check to make sure that you got the same standard error, right?
So similarly in 11, the Z critical value and the margin of error,
Right,
we would
all of that. Yeah, that's just to double check your numbers.
Okay, great. Okay, thank you.
Yes,
Okay.
exactly. Yes. This in here in parentheses, yes. That's just to double check and make sure that you got the same thing, right?
Great.
Yep.
So
Okay.
I have a question, Professor. So
Sure.
for example, like how you mentioned on number 10, just because you were talking about it, you would want us again to like plug in the formulas and then write it out like this, correct? Does that make sense?
What do you mean?
Like, because usually when there was a question like on, I guess, again, like lab 3, I would fill in the problem, like the formulas, and then it would say, is this less or something or greater? I would put in the formulas, and then I feel like it is lesser because of this point something is less.
Yeah.
Like, that's how I would write it. So do you want us to write it like, again, how you showed us the formula sheet, like number 10? Do you want us to always write it like
where you put in the formula? If you want to put in the formula, you can in here.
Mm-hmm.
Yeah, you can put in the formula because you have a little bit more time. But if you're running out of time, you don't have to put in the formula.
Okay.
Right. And also the other thing too that I've noticed on the labs is that some students are actually like writing out everything that they're writing out and explaining what it is that they're doing.
Mm-hmm.
You know, please don't. That's a lot more reading that I have to do, and it slows down my grading. And also it also limits the amount of time, right? So if you're writing out the explanations, and especially on a test, you don't want to do that, right? You want to make sure that you're giving yourself enough time and not writing stuff out. Just show me the calculations. I can tell just by what you're writing what it is that you're doing.
Okay.
Usually I can tell. Especially if you're using like Canvas Math Editor, I can immediately see what it is that you're doing. And it's a lot quicker for me to figure out, okay, here's where you went wrong. Or, great, this is perfect. Yeah, so don't write out the formulas. You don't need to.
Okay. Yeah, because I'm trying to like see like if I can like show you. I want to like go through my phone and look at the labs because I know you can review them and show you like on the computer because obviously I can't screen share. That'd be like 1,000 times.
Oh, I know, right?
But yeah, because like I'll figure it out, and then when I see it, I'll show it.
Okay. All right, sounds good. Yep. Sounds like a plan. All right, any other questions?
Mm-mm.
You guys good?
This was a big unit.
Oh my God, I know.
I'm so happy to be in the understanding place where I almost understand all of it. It's
right.
That was one. So
I know.
Is the next unit as much material as well? Yeah.
Well,
okay.
It's ANOVAs. ANOVAs are huge. It's a lot of calculating. So
Okay.
the next unit is also a little intense.
Okay.
Yeah. What's really cool though to remember though is that chapter 9 and chapter 11 are really similar.
Yes, they were.
If you understand chapter 9, chapter 11 is going to be a breeze.
Yeah.
Right?
True.
Yeah. So it's really chapters 8, 9, and 10. 10 is intense, and 8 as well, because now we're dealing with terminology and just this, the hypothesis testing and all that good stuff. And the null, the alternative, and all that. So trying to keep it all straight. But yeah, because if you can figure out a single sample t-test, the related samples, you're basically turning the related samples into a single sample t-test, right? So yeah, so that's so yeah, it is a lot of material. I know. I feel terrible. I'm like, oh my God, there's so much here. I do. I'm like, I'm suffering for you guys.
Yeah. Okay.
So yeah, so hopefully you keep practicing. You know, so there's problems at the end of the chapters. If you have time, you can do a few of those odd numbered ones to check your answers and make sure that you really do understand how to do all of it. And then I will be opening up the exam soon. So when you feel ready, you can start. And you'll have 2.5 hours for this exam because there's a lot more calculations. And again, same thing as I said last week, do the problems first, go through each of the problems first, and then go through the multiple choice questions. But watch your time.
Yeah, when I did that, oh my God, it was so much easier for us.
Was it?
Yes.
Good. Yeah, because a lot of times what trips us up is as you're going through the multiple choice questions, you're like second guessing yourself, or you're looking stuff up and you're spending more time, and then you run out of time to do the calcs. So go to the calculations first and then go back and go through the multiple choice questions.
A question that I have, Professor, is could you show us, because I forget how you said it, but like where on number 10 it shows like H is a capital letter, like how do we minimize the numbers, like 1 next to the
That's
letter?
in editor.
Oh, okay.
Remember in Canvas editor? So in step 1, you go into Canvas editor, you're going to do H, you're going to do H subscript 0.
Oh, okay.
And then move out of that. No, not equal. Sorry. This is one thing that students do as well. An equal, it's not an equal, it's actually a, oh my gosh, what is going on here? Why is it doing that? It's not showing up. That's weird. Huh. And then let me see if it, let me go to the Greek. I'm going to write this out real quick. Mu, and was this, I don't remember what the problem was here. Oh, it's mu1, right? No, number 10? No. What is it?
Number 10.
Yeah, it is. Which one am I? Oh, this is 13.
Yeah. So the mu is
mu1, it's going to be, so it's going to be in basic. So it's mu1. And they're saying significant difference. So operators, wait, nope. Where is it? Relationships, here we go. Not equal to. So there's where the not equal to is under relationships. Here's the not equal to sign. And then the less than and greater than. This is going to mean mu. Whoops. mu2. Let me see. Yeah, it's not, that's weird. Huh. It's not doing the, for some reason, I don't know why it's not doing the the colon. So it's fine if it's like this.
okay.
Actually, that's not H1. That's actually H1. I did that wrong. You guys didn't say anything.
Oh,
Tired.
yeah. So much reading and so much like writing and taking notes. Like, okay.
Huh. So H0 is actually, no, that's not doing it. Okay, so mu, let me go back, do this right. Where's equal? It's not showing up. Let me do it here. Equal to, whoop, equal to, oh, go back down. mu1 is equal to u2. There we go. That's the null. Right? And then the alternative would be the mu1 not equal to mu2. Okay? So that's how you would actually write it out.
Great.
Okay? So using the Canvas math editor. And I would suggest as you're doing these, right, rather than putting it all into one, insert the equations as you go, right? So do one line like I did here, right? Do estimated standard error, right? Insert the equation. Do your T, open up a new insert equation, right? And do your next line, right? So this would be H1 or HA, depending on you know who you ask. So it's mu again, subscript 1, and then go to your relationships and do not equal to Greek mu subscript 2, right? And insert equation, right? Rather than going to the next step, right? So that way it's nice and neat, right?
Okay.
And it keeps you, you can keep track of what you're doing, right? Okay. Cool deal.
Mhm.
Excellent.
Okay.
Cool.
Great. I gotta go. Thank you.
Yeah. All right. Thanks, Lindsay. Well, we're pretty much
Okay.
done. So tomorrow we're gonna have another review session tomorrow, 10:30 to 12. So if you want to pop back, you can.
I'll be at work, but
Oh, okay.
bye.
I'll post the recorded session.
Awesome. Thanks.
You're welcome.
Bye.
Thanks. All right. So that's it. That's it for today.
Okay.
All right. So I'm going to stop the recording. Oh, I'm not sure. Let me go back. I'm going to do a stop share and a stop recording.
Okay. So now I can show you, Professor, because I guess it was